Hello students, we're going to be talking about linear equations in two variables, and we will begin with the linear equations, what a linear equation is, how to identify a linear equation, and then also to determine the forms of an equation. There are two forms or two ways of writing a linear equation. Now, when we are given an equation and we just look at the equation and we're asked, is this equation linear or not? Then we look at the variables and the exponents on the variables. If the exponents are 1 on both the x and y variable, then this equation is a linear equation. And to be a linear equation, it means it's going to graph as a straight line. So another example of a linear equation could be something like x equaling 2y plus 8. Each of the variables, x and y, are to the exponent of 1, and so long as they're to the exponent of 1, it is, yes, a linear equation, which means it's going to graph as a straight line. Now, if I alter either the x or the y variable by doing something like 2x squared plus y equaling 4, because the exponent on the variable x is a 2, this is not linear, and this would not graph as a straight line. Or if we alter the y and we put something like 2x plus the square root of y equals 4, that again is not linear and it will not graph as a straight line. So in this section we're only talking about linear equations such that if you ever graphed it, it would graph as a straight line. Now there are two ways to write a linear equation, two forms of a linear equation here in number 2. The first way, written here in red, is standard form. Ax plus by equals c. So here's your variables x and y. The a, b, and c are just numbers. So if I put a number in for a like 3 and a number in for b like 4 and some number, anything I want for c, maybe 8, then that's considered a linear equation written in standard form. So in other words, the x's are first, then the y's, the equal sign, and the constant. So another example could be 1/2 x minus 7y equals 12. That is in standard form. The x's are written first, then the y's, then the equal, and then the 12. So those are standard form. Another form of an equation is the slope-intercept form, y equaling mx plus b. So your variables y and x are going to stay in position, and the m and the b are numbers. So if I write y equals 3x minus 7, then that is in the standard form, or the slope, no, not the standard form, that is in the slope-intercept form. The y, then the equal, then something times x plus something. So when I write y equals, that's going to place me in position to be in slope-intercept form. Then I put a number in front of x and some number on the end, and it is in slope-intercept form. What's special about slope-intercept form is note that the m is the number in front of x, and m is slope. So the slope of the 3x minus 7 line is 3, and the slope of the 1/2 x plus 4 is 1/2. The other number of great significance in this form is the constant on the end. And what the constant on the end does for us is it tells us the y-intercept, where this line is going to cross the y-axis. So the first equation has a y-intercept at the point 0,7, and the second equation has a y-intercept at the point 0,4. So both of these forms of equations have advantages, and we'll most frequently really use the slope-intercept form. Now, other information in this section of importance is how to graph. Okay, and we're going to graph staying with the linear equations. So we go into a linear equation in which we're going to have an x and a y variable. Then we're going to need an x right here and a y-axis, which is why we turn to a piece of graph paper. So when we start graphing linear equations, we often just build a table, we make up x values, and then solve for y. So if x is 0, this equation would say 2 times 0 plus 4y equaling 8, which would be 4y equaling 8 and y equaling 2, which gives you the point 0, 2, which is going to be graphed. If x is 1, this would be 2 times 1 plus 4y equaling 8. And for sake of room, I'm just going to say you'll subtract 2 and then divide by 4, and this will be 6/4, which is really 3/2. So it's the point 1 3/2. If you put an x value of 2 in, it's 2 times 2 plus 4y equaling 8. So then you would subtract 4 and divide by 4 and get a result of 1. If x is 3, it's 2 times 3 plus 4y equaling 8. You're going to subtract 6 and divide by 4 and get 1/2. And then if you take 2 times 4 plus 4y equaling 8, you're going to subtract 8 and divide by 4 and get 0. So here's many points. We really don't need this many. 2 or 3 would be sufficient, but I'm just trying to emphasize how you graph. So if I were to plot these points, the first is 0, 2, 1, 2, there's that point. 1 3/2, 1, 1 1/2, 2 1, 2 1, 3 1/2, 3 1/2, 4 0. Okay, so I'm going by 2's here. Once you have your dots or your points graphed, then when you connect them, you see that you do have a straight line. So that's my first graph. Let's come down and look at another graph. The second one here is in the slope-intercept form because it says y equals mx plus b form. This last one we did was in standard form because it's in the ax plus by equaling 8. X's, then y's, then equal, then number is standard form. And number 2, y equaling, is our slope-intercept form. Somehow it just says form, but it's slope-intercept form. Okay, so we're just going to do 3 points on this one to save a little time. If x is 0, y equals 3 times 0 minus 6, which is a negative 6. If x is 1, y equals 3 times 1 minus 6, which is a negative 3. If x is 2, y equals 3 times 2 minus 6, which is 0. We could just keep making up x values and creating more points, but 3 is enough. 0, negative 6. Let's go by 2's. 2, 4, 6. This is 0, negative 6. 1, 3. I didn't go by 2's on my horizontal. 1, negative 3, 2, 3, and 2, 0. So here would be our straight line. And on this one, because it is in slope-intercept form, we can say right now the slope is 3 and the y-intercept is 0, negative 6, which we confirm 0, negative 6 also in our table. So those are just some basic ways of graphing a linear equation. Now we have some special case linear equations. They create straight lines when we graph them, but they're unique in that the equations have only one variable, meaning the equation only has x or only has y. So example 1 says y equals 3. This is only the y variable. So if you build a table of values, the entire y column is going to be always 3. The x column, because x is not even in the equation, then x can be anything we want. Maybe 0, 1, 2, maybe 100, whatever we want it to be, the y will always be 3. So if we plot these points and take a look at what the graph is, 0, 3 is here, 1, 3, 2, 3, and then 103 would be way out here off the graph. But then when you draw your line, you will see that it's a horizontal line. So anytime you have only the y variable, you will have a horizontal line. And they call horizontal lines constant functions. So if you ever see in the book the word constant function, then that means it's a graph of a horizontal line and its equation will only have the y variable. Number 2 is an equation that only has one variable in it, but it's the x variable. So in the table, the x will always be negative 4. The y will be anything we want it to be. Again, 0, 1, 2, 100, 1,000, 10,000, whatever you want. Okay, negative 4, 0, 1, 2, 3, 4. Negative 4, 1, 1, 2, 3, 4, up 1. Negative 4, 2, left 4, up 2. Left 4, up 10,000, whatever. When you connect the points, it's going to be a vertical line. So an x equals something equation will be a vertical line. or an equation that only has the x variable is going to be a vertical line. So look here at number 3. Again, it looks like an equation we've seen before, but you have to pay close attention and take note that only the x variable is in it, y is not. Therefore, when you graph this, it is going to be a vertical line. So I'm going to clean it up a little bit. I'm going to subtract 3 off of each side, making 2x equal 4. And then when I divide by 2, x equals 2. So these equations are the same equation, but this one is going to be easier to graph, this form of the equation where it's simplified. So if x is 2, in the table, every x value will be 2, and the y can be any value we want it to be. So that all I can do now, or what I can do now, is plot the points 2, 0, 2, 1, 2, 2, and it does confirm that it is a vertical line. Okay. Then looks like we need to pause or stop the equation, this lesson at this point, and I'm going to have a follow-up video recording because this is not the entire section. We have more in this section, but we need to pause it at this point in order to keep this recording from being too long.